For the protection of critical infrastructures, deep packet inspection is unavoidable. The forensic analysis of malware activity in PCAP traffic, however, is often a costly and time-consuming task. Manually scanning the traffic with tools such as Wireshark is often tedious and, due to the many packet details, overwhelming. In this video, we present Eventpad, a dynamic behavioral analysis tool to quickly detect patterns and analyze malware activity using visual analytics. The Eventpad system enables users to study PCAP files by dissecting this traffic with T-Shark. After selecting a PCAP file, users can select which properties they want to analyze. Opening a file results in an options panel, enabling users to decide how the traffic should be split. Let's start by analyzing Jigsaw traffic and grouping the data by Samba session. This results in one large sequence. In Eventpad, we represent every network packet as a block. The sequence view shows an overview of all network conversations as sequences of blocks. Hovering the mouse over a block results in a pop-up, showing all the dissected Wireshark properties of that block. Users can define rules to highlight properties that are of interest. Double-clicking a block results in a pop-up where users can add a constraint to the corresponding block. Now only blocks adhering to these constraints are replaced by the rule's right-hand side. For the right-hand side, users can design their own blocks. This immediately shows all file open events in the data. A minimap can be used to discover patterns in larger collections of data. The icicle plot shows an overview of all the rules that are applied in the system. This shows that 33% of the data corresponds to open packets. The rule view shows an overview of all rules applied in the system. Rules can be toggled on or off to study their effect, and are applied from top to bottom. Let's load in a rule set that highlights all open, reading, writing, and closure of files in yellow, purple, blue, and pink blocks respectively. This shows that we have many duplicate blocks in the data. Inspecting the duplicate blocks in a tabular view shows that these packets correspond to request and response messages. Let's focus on the request packets for now. For a quick selection, we can use the response flag histogram. Selections can be saved in a new attribute. This results in the creation of a new context. Selecting the context now only shows request messages. Inspection of the new context reveals the repeated open and closure patterns involving delete events. We can use a visual regular expression language to capture this repetition in a new attribute. Different regex operators such as iteration and sequential composition can be applied using an equation editor similar to Word. This results in the creation of a new attribute. Let's call it rule 0 for now. Grouping the traffic by this attribute shows that the sequences show a lot of similarity. The repetition of open find close patterns correspond to directory traversals before encryption of the file can take place. This is also highlighted in the minimap. To gain better insight in these patterns, let's split the traffic based on file nesting. This shows a lot of open, find, and close behavior across different files. Since the number of read and write messages depend on the size of the file, we can use regular expressions to also simplify these sequences using rules. The number in the upper right corner shows how many blocks are contained in the new block. The tabular view now shows which packets correspond to these blocks. Stacking the sequences and sorting them by frequency shows the most common access patterns in the traffic. Inspection of the deleted files show that a lot of JavaScript files were deleted in a similar way. Inspection of the write packets show that those same files with a .fun extension were added to the Samba share. In order to study the internal mechanics of the virus, we first load in a rule set that compresses all read, write, and open find close patterns. Inspection of the sequences in an icicle plot shows how often every sequence occurs in the traffic. The icicle plot shows how often every block occurs with respect to its position in the sequence. Using alignment, we are able to discover very distinct patterns that are spread over the PCAP file. This reveals two main patterns, namely the recursive traversal of directories and encryption patterns of files. This shows how we can quickly identify malware patterns in over 700,000 network packets in just a few minutes using visual analytics. Let's have a look at the Cryptex virus. In this use case, request and response packets have already been merged into one packet. Users can enable a line chart showing the number of times rules have been fired in the data. This shows an encryption burst at 8:30 p.m. After applying a similar rule set as in the Jigsaw traffic, the icicle plot and sequence view show examples of packets that apply to multiple rules at the same time. Using the search query interface, we can look for all compound packets by stacking two wildcards on top of each other. The line chart shows that these requests only occur before and after the encryption burst. Inspection of these packets in Wireshark show that these Samba packets indeed have multiple request headers. Although the usage of compound requests are valid with respect to the protocol, this was unexpected. Scrolling through the data reveals a fine burst along with repetitive behavior. Let's inspect the file patterns by grouping the traffic based on file nesting. Sorting the sequences alphabetically and inspecting the data in the minimap shows that some of the sequences occur more often than others. We can inspect the duration of open-close patterns by creating an arc diagram, showing the beginning and ending of every pattern. Here we can see that during the burst, small arcs represent the encryption of files, and the larger arcs correspond to the opening and closure of directories. Again, showing how we can gain insight in hundreds of thousands of packets in just a few minutes. This concludes the presentation of Eventpad, a dynamic behavioral analysis tool for rapid and cost-effective insights in raw PCAP traffic. Thanks for watching.